Hello, in this video I will go over the answers for the review for quiz number 7. So number 1, we're trying to find the area to the right of 29 under a normal distribution. The mean is 24.5, standard deviation is 3.45. We have to convert the x values to z values. 24.5 converts to 0. Using the z-score formula, we have 29 minus 24.5 divided by 3.45. That's going to be equal to 1.3. We look up 1.3 in table E. And remember, when you look up the area in table E, it's always the area to the left. So 1.3 is 0.9032. So that's a left area, 0.9032. We want the area to the right, so to find the area to the right, we always take 1 minus 0.9032, and that's going to give us 0.0968. So the answer is 0.0968. The second problem involves computing a cutoff score. So we have the top 8%, 0.08, and then we compute 1 minus 0.08, which is 0.92. This is the area that we look up. So 0.92, and we look up this area to help us find the z value so that we can determine x. The cutoff score is the value at the threshold of the top 8%. And then keep in mind the mean is 580, standard deviation is 96. So looking up the area closest to 0.92, we go back to table E. The area closest to 0.92 is 1.41. So, that's going to give us the z value, 1.41. And now we calculate x. X is the mean, 580, plus the z value, 1.41, times standard deviation is 96. That computes to 715.36. Thus, the cutoff score, and I'm going to round this to a whole number, is 715. Now number 3, we're trying to find two cutoff scores because we're given a middle 48%. So whenever we're provided with a middle percentage, we divide it by 2. Half of that area goes on the left side, the other half on the right side. So 48% divided by 2 is 24%. We have 0.24 on the left, 0.24 on the right side of the mean of 12,000. Standard deviation is 1,500. Once again, we focus on this left tail area. Keep in mind that half of the area is 0.5. So 0.5 minus 0.24 gives us 0.26. So we need to find this area, or the area closest to it, in our table, and then use it to find the z value. So if we look for the area closest to 0.24 or 0.26, it'll be this area. So we're looking for 0.2611. To the left, we have negative 0.6. Upwards, we have 0.04. Thus, this z value is negative 0.64. Using symmetry, the value on the right side is positive 0.64. And now we have all the components needed to compute the two z-score or x scores. So x sub 1 is 12,000 minus 0.64 times 1,500. That's 11,040. X2, the other cutoff score, is the mean 12,000 plus the z-score 0.64 times standard deviation 1,500, 12,960. So the middle 48% is between 11,040 to 12,960 videos. In problem 4, we're using the distribution of sample means. So it has a normal shape. The mean is 20. We're looking for the sample mean to be greater than 23, so this area. And one of the clues that lets us know we're working with the distribution of sample means is we are provided with the sample size. In this case, it's 50. And of course, standard deviation is 4.3. So our goal is to calculate the z-score. 20 converts to 0. Remember, the mean always converts to 0 on the z-axis. Let's convert 4.93. So the z-score formula for the distribution of sample means is this formula here. X bar minus mu divided by sigma over radical n. So to calculate this, we put all our values in. 23 minus 20 over 4.3 divided by radical 50. And I'll demonstrate the computation using a calculator. So we have 23 minus 20 divided by 4.3, and that's over radical 50. And it's important to put parentheses around the numerator and denominator to ensure you get the correct calculation. 4.93. So now we look up 4.93 in our table. Remember, any z-value that's greater than 3.49 has an area to the left of 0.9999. So that's this area. And we want the area to the right, so we calculate 1 minus 0.9999, which is 0.0001. Number 5, we're still working with the distribution of sample means, but now we have two x values, or x bar values. We're looking for the area between 9.8 and 12.3, so we desire this area. N is 40, standard deviation 2.9, and the mean is 10. So we have to convert all three sample means to z values. The mean 10 converts to 0. So following the process I described above on the calculator, we compute the first z value, 9.8 minus 10, over 2.9 divided by radical 40. That's going to give us negative 0.44. And the other z value for 12.3 is 12.3 minus 10 over 2.9 divided by radical 40 is 5.01. We look up both values in table E. So 5.01 is greater than 3.49, so that's going to give us an area of 0.9999. Now we look up negative 0.44. So negative 0.4. 0, 1, 2, 3, 4 is 0.3300. And remember, when we're finding the area between two z values, always subtract the smaller area from the larger area. That's going to be 0.6600, and that's our answer. Thanks for watching the video.